Hey you, yes you, sitting in this classroom, forced to watch a bunch of videos on physics, though you just want to do not physics. Have you ever wondered how deadly some wood and string can be? Well, you first might want to get checked out by a psychiatrist or something, but after that, look no further than the act of archery. Now, what is archery? Well, 64,000 years ago, some Neanderthals added some wood, string, and pointy wood together to make the bow and arrow. Around 5,000 years ago, the Egyptians began one of history's greatest trends by saying, "Hey, we can kill people with these." Later, in the first millennium AD, the Europeans decided, "Hey, we can kill a lot of people with these in wars." By the 1500s, people started using boomsticks. So people decided, hey, let's stop killing people with the bows and just use them as a sport. Now, people aim at a wide variety of targets that are not humans, and the world is good and without war. Since we have an arrow with a mass and a drawn force, we need to figure out how this can get our arrow to accelerate and move. Knock knock. It's Sir Isaac Newton, and he has 3 hip new laws. But we only care about his second one for now. Newton's second law relates 3 quantities: net force F, mass m, and acceleration a, in the equation F net equals ma. By moving it around, we can get A equals F net over m. Since the large force drawn in the bow is transferred to the arrow and the mass of the arrow is small, the acceleration will be large. Hey, wow, that's pretty large. With acceleration, the arrow can go from an initial velocity of 0 to a final velocity of more than 0 very quickly. Now that we know we can get a large acceleration and velocity, can we shoot stuff? No. We need to use a new property of motion that's gaining some momentum. We will call it momentum. Momentum is the product of mass m and velocity v, and is defined as the letter P, which stands for penetration. Actually, P is for pedere, which is Latin for to go toward. It's a third conjugation verb. Wait, this is turning into a different kind of class. With arrows, archers, who are not physicists, assume that velocity does not change much with bigger masses, meaning as mass gets big, so will momentum. And since momentum allows penetration, the bigger the arrow, the better the pen. Oh wait, this is turning into a different type of science. We're sorry. Since the arrow will stick to the target, we will get a perfectly inelastic collision, which means momentum is conserved, but kinetic energy is not. Some of the kinetic energy is lost to other energies in the form of sounds, vibrations, and oscillations. Wait, the arrow moves forward but oscillates? That sounds like an Archer's paradox. Since momentum is conserved, we can maximize our penetrating force by making the arrow hit the target at a perpendicular angle. And now, for your viewing pleasure, a demonstration of archery. Using our artisan bow and arrows, we will show you the physics that we have discussed today. When doing archery, you first nock the arrow and pull the string back. This is achieved by your muscles and the power of manpower, which exerts force onto the string. Newton's third law states that every action has an equal and opposite reaction. This means that there is now tension in the string, equal in magnitude, to the force that you are exerting on the string. This force you are exerting is called the draw weight. Now, all you gotta do is aim and fire. Easy, eh? Aim, pull back and fire. Well, no. Using our specialty bow, we will get to the moment you have all been waiting for. When the bow has a small draw force, the acceleration will also be small, meaning our arrow goes nowhere. Increasing the force increases the acceleration, allowing the arrow to take flight. However, increasing the mass by a large amount with the same force will have interesting results. Wow, that's bad. Well, that's all the time we have. I know what you're thinking. No one died. Sorry about that. But you know, you don't always get what you want.